Okay, so for 7-2, we're talking about inverse functions. And so what I want you to be thinking about is, not the bell ringing, but give an example of a function whose inverse is still a function. So I want a function where when we take the inverse, we get a function back. And then a function when we take the inverse that the result is not a function, right? It won't pass that vertical line test. So let's look at, first of all, kind of as an intro, inverse relations, right? So inverse relations are found by reflecting the ordered pairs across the line y equals x. Essentially what we're doing is we're switching x and y. So as we look at these, let's look at a quick example. Here is a relation, right? These are forwarded pairs. Relation compares an input and output x and y. The domain here would be -1, 2, 3, 5, and the range would be 1, 3, 5. And so when we think about these 4 points, we could plot them on a graph. -1, 1, 2, 3, 3, 5, and 5, 5. Then we could connect them, right? We have those 4 points. Now, we want to reflect across this line. The easiest way for us to do that is just switch the ordered pairs x and y. So what we have here is we have, instead of -1, 1, like we saw over here, we flipped them. Instead of 2, 3, we have 3, 2, 5, 3, and 5, 5. Notice 5, 5 stays the same. It lives on this line. When we reflect it, it stays on the line. Now, if you look at this, look at the red. It is a reflection. If you were to fold up your graph across that green dashed line, it would sit right on top of itself, right? Okay, so by switching the ordered pairs and replotting them, this red over here is the inverse. So this was the original relation. We find the inverse by switching the ordered pairs. Okay, or switching x and y within each ordered pair. Notice the relation is a function. When we look at this, it passes the vertical line test. However, the inverse does not pass the vertical line test. It is not a function. So inverse not passing that vertical line test makes it so that it's not a function, right? All of these vertical lines kind of lead us to that. Something else I want you to notice here. The domain of the relation is the range of the inverse. And vice versa. The range of the original function is the domain of the inverse. So the domain and range flip. The domain and range flip here, right? Originally it was the domain. When we take the inverse, it's the range. Originally it was the range, take the inverse, it's the domain. Okay? And then this one ended up not being a function when we took the inverse. Kind of clear some of that off so you can get a better view of that. Okay, so that's an inverse relation. Now, we can also write inverse functions, and as we look at those, we're talking about functions that undo one another. Back in relations, we were just looking at the ordered pairs. Now I want to actually look at the function. The way we write this is f at x and f inverse of x. That -1 implies inverse. Think matrices. When we did matrices, that meant the inverse of A, right? That was a button on our calculator that helped us take the inverse. So when you see that little -1, that implies inverse. Okay? Now, we've talked about inverse functions a little bit already, right? Inverse operations, plus and minus, multiply and divide, and then squaring along with square rooting. Those are all inverses. In geometry, you learned about sine and sine inverse, right? So you know inverse functions. Well, we can use these to help us actually write an inverse function. Let's look at a quick example. Here's a function, 5x minus 7. Great, 5x minus 7. What is happening here? Well, x first is multiplied by 5, and then we subtract 7. 5 times x, then minus 7. So to do the inverse, we have to go in the opposite order. We're going to start by adding 7 and then dividing by 5. So we're going to do x plus 7, and then we'll divide that by 5. X plus 7, and then that's divided by 5. Notice we worked backwards. And so by finishing with subtracting 7, we're going to start with adding 7. So that it's always that idea of inverse, working backwards, the opposite way. Okay? We can check our answer. check your work. You should know if you have the right function. You should know. Take a number, plug it into the original. So I'm going to plug in this 1 into my original function. 5 times 1 minus 7. So 5 minus 7 is negative 2. So for the original function, I have an ordered pair 1, negative 2. Now if I plug it into the second function, then negative 2 plugs in, and negative 2 plus 7 is 5. 5 divided by 5 is 1. I have an ordered pair negative 2, 1. The order pairs are switched. It worked. Okay, that's a great sign for us. So as you're looking at this, this is one way to check and know if you did it exactly right. Okay. In a little bit I'll show you another way. But inverse functions, use the opposite operation, let that guide you and get you where you need to be. Okay? Now, I want to talk a little bit more about inverse functions in a different way. And that different way is going to rely on us going back to what we did from the very beginning, which is switching x and y from our original discussion. So when we started this whole thing, we talked about switching x and y. And we're actually going to do that here too. Okay, let's look at an example. And I'm going to show you the whole example, and then we'll go back and talk about bits and pieces. We started with this function. This is the original. Y equals 5x squared plus 3. Then, what we did here, I'm going to highlight it so you can see it. We switched x and y. X and y got switched. We just switched them around. That's how we made the switch. And then this right here is a great function, right? Being able to go work backwards. Most of the time, if we're going to graph something, we need it as y equals. So it was important that we figured out how to solve for y. So we subtracted 3 from both sides, divided both sides by 5, and then took the square root of both sides. And when we took the square root of both sides, took the square root of everything in here. So these parentheses look kind of funny, but that's how that works. Notice, plus or minus square root, right? Because there are always two answers for when you take the square root, the positive and the negative. So whenever you take an inverse with the square root, please, please, please remember to put the plus or minus. That'll make me much, much happier. And it'll make you happier because it makes sense. Solve for y, then check it with Desmos. Check it and see if you did it right. All right, let's talk about how that works. We can go to Desmos and we can plug it in. And when we plug it in, we're going to want to plug in this original function right here. And we're going to want to plug in this new function. And we're going to want to use the plus or minus. Okay, so get those two plugged in right now. You try. You try it while I'm erasing. Did you get those two plugged in? Notice I used blue and red because that's kind of been the colors the whole time. Doesn't matter if that's what you used. Also notice in the second one I designated it with a little -1 to show me that was the inverse. Desmos doesn't need that -1. Okay, that's just more for us so we know. So I got them all plugged in. I got 5x squared plus 3. And then I have the positive square root of x minus 3 divided by 5. And I have the negative square root of x minus 3 divided by 5. And then I also am going to graph that original green line that we looked at of y equals x. So here they are. This is the original. This is the inverse, positive and negative square roots. If you look, see how this is kind of highlighted over here? That's why this one's a little bit thicker. And that's showing you that really, with just the positive, we only get this top part. When we introduce the negative, that's when we get the whole thing to get this perfect reflection of blue over the top of the green to kick out the red. Okay. And that makes sense too. Look at this. We have an ordered pair of 1, 8. Over here, we have an ordered pair of 8, 1. That's glorious. We love when that happens because that means we inverted correctly. We switched x and y correctly. Okay, so this one totally worked out. So our switch and solve worked perfectly. Okay. If we would have graphed it and it wouldn't have worked perfectly, then we know we did something wrong. We're going to have to go back and look at our work. You should always, always, always know if you got it right or wrong. Okay? Looking at that now, let's go back and think about this question that we started with. Give an example whose a function whose inverse is a function. Give an example of a function whose inverse is not a function. Now both of these unfortunately were not a function. Okay? The red ones for both, neither red graph passed the vertical line test, which is kind of a bummer, right? It'd be great if one of them did, but here's what this tells us. If we do the vertical line test, it'll tell us yay function or nay function. And as we look at this, both of these blue ones pass the vertical line test. Passes the vertical line test. Vertical line passes all over that whole graph. It's never going to double intersect. Here's how this applies to these, or to inverses. Instead of the vertical line test, we can try a horizontal line test. And the horizontal line test will tell us if the inverse is going to be a function or not. So, if we do the horizontal line test, the blue one does not pass the horizontal line test. The blue passes the vertical, but fails the horizontal. Passes the vertical, fails the horizontal. Because the blue fails the horizontal, that means the red will fail the vertical. And then the same thing applies over here. The blue fails the horizontal, so the red fails the vertical. Now because the red passes the horizontal, the blue will pass the vertical. So that vertical and horizontal line test goes hand in hand. That would be a good thing to get written down, because that really helps us answer that original question. Okay, so make sure you understand that. Probably most importantly, master the art of the switch and solve. Switch them and solve them. Switch them and solve them. So make sure you have this down, please. Please, please, please. Are you ready to work with it?